So let's start off with your inputs. Obviously your inputs, all you have is just X, Y, and Z. Now, what are all of these inputs doing? Like this one, X times Y times Z. Well, they are multiplying, and when they multiply, it is your AND gate. So let's do that with D. Now, we worked with that. Now here you have your Y prime plus Z. Now your X is fine. I mean your Z is fine. But your Y prime here, it is being primed. So what happens if it's just Y prime? Well, it's just your NOT gate, because your Y prime is like saying not Y. So you see this Y here. Now one way I like to do this is, since this is a separate case, because you worked with this first and then you work with this second. So your Y prime here, you get Y, but we have to make it not Y. And how do we make it not Y? Well, your NOT gate. And then you have your Z. Sorry. Okay, so this is what my Z looks like. And these two inputs are being added. And when they are added together, what do we get? Well, when they are being added together, it is your, if you said OR gate, you are correct. Now here, since this is your Y, you could in a way come here and connect it like that. And your Z, well, your Z is just your Z, so you can come here, bring it all the way down here to over here. And that's what you get. But now, to connect these two, well, just like your Boolean expression here, this expression here is connected with this. How? Well, with this plus sign right here. Well, with that plus sign, what is the logic gate for that? Your OR gate. So you're connecting these two essentially like this, with a big OR gate. Simple enough. And that's it. That is your circuit, the smallest circuit than we had last time. One way to check it, like I mentioned earlier, is to use your truth tables and assign 0, 0, and 1s to these inputs right here. Look at this entire thing. You see all you have is just 3 different inputs, like X, Y, Z. So let's start out with that. X, Y, and Z. Now, with these truth tables, you can assign binary numbers. And so to do that, you can do 0, 0, 0, or 0, 0, 1, or 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 1, 2, 1, 2, And by the look of this, I need one more. Alrighty. Now that you have this, well, over here you'll notice that you have your y prime. Well, let's incorporate that. Y prime. So here you have your y's. We already assigned them values. Now let's just for a sec, since we assigned values to this, let's just focus on your y's. So if you want to, you can cover up your x and your y's. But for now, I'm just going to tell you that since I can't do both at the same time, I will tell you to just concentrate on your y values for this y prime. So look at your y prime. What is y prime? Well, y prime, we already discussed many times that y prime, you're just taking the opposite of whatever value of y is. So here, the opposite of 0 is just 1. Opposite of 0, 1. 0, 1, 0, 0, 0, 1. Because see, all we're doing is just taking the opposite of y, so you're going to have to go through every single value and do the opposite for each of these. So the opposite of here of 1 is 0, and you keep going down the list, and that's what you get. Now, let's concentrate on this part. X, Y, and Z. X, Y, and Z, you are, hold on if I can get this right. There we go. X, Y, and Z here, you're just multiplying. So, let's focus on that. X, Y, and Z. Let's multiply 0 times 0 times 0, which is 0. 0, 0, 1, you get 0. 0, 1, 0, you multiply these and you just get 0. And remember, with this part, all you're doing is concentrating on your x, y, and z values. Forget about y prime for a sec. So if you want to, you can cover up y prime like I'm doing right now, but just cover up y prime if you need to. But for the most part, all you're doing is just multiplying x, y, and z values. So let's multiply them. 1 times 0 times 0 is just 0. 0 times 1 times 1, 0. 1 times 1 times 1, well, that's just 1. 1, 1, 0. That essentially just 0. And here is just 0. So now that we got that out of the way, now let's do this other expression, because we're going to do these one by one. So we got this part down, so this is done. Now plus, now you have your y prime is being added with z. So just like I said earlier, look at your y prime values and look at your z. These are the only two that we're concentrating. Forget about x and y right here when we're doing with this, because this is all we're using. Y prime and z, because these are the only inputs that we're dealing with. So let's take y prime and z. And what are we doing with these values? Well, right here, we're just adding them. So add 1 plus 0, you get 1. 1 plus 1, like we said earlier, is just 1. 0, 0, well, that added together is just 0. Here, 0 plus 1, that's just 1. 1 plus 0, that's just 1. 1 plus 0, that's just 1. 0 plus 0 is 0. 1 plus 1 is 1. Great. Now, this is getting kind of bigger for my page, but here you have your y prime plus c, adding that to x, Y, and Z. So look at this one. Look at these values. 0, all these values. This corresponds to this, and we're adding it plus these other values. So do like we did before, add them together. Add these two columns together. So 0 plus 1, that's just 1. 1. Here is just 0. 1. 1. Hold on, let me see if I'm doing this right. 0 plus 1. 1, 1, 0, 1, 1. 1. Another 1. 0, 1. And that's what your truth table for that looks like. For this Boolean expression, this is what your output should be. So if you come over here, we're gonna only look at one row at a time, only one row. So let's say you were to pick, I don't know, this row right here. Okay, so since you made x 1, we're gonna make it 1 here. And y here is just 0. Okay, so that's just 0. And your z over here, and your z over here is just 0. Alrighty, so here if you do it, x times y times z, then what is your output? Well, that's just 0. Now, since y over here is 0, now since we brought it down here and brought it all the way over here, guess what? It's your not. So take the opposite of 0. Well, the opposite of 0, that's just 1. And z over here is 0. So you see the 0, we're going to carry it and bring it all the way down here. And that's just your 0. So your OR gate here, 1 and 0. Well, your OR gate for 1 and 0, that is just 1. Sorry for the long pause, but I had to breathe. 1 and 0, that is just 1. And then here, you have your 0 value and your 1 right here, and this is your OR gate, so 0 and 1, and since this is your OR gate, this is kind of like x plus y. Add these two values together, and what do you get? 1. And now you look at this. Right here, your output is 1, and we looked at this one, so it's 1, 0, 0, 1, and okay, since we did 1, 0, 0, this is what your fourth row. So let's look at our fourth row and our output in our truth tables. 1, 2, 3, 4. Hooray! We got a 1. So that's one way of knowing that your circuit is actually your truth table, that your circuit is actually corresponds to your Boolean expression. You can go through all of these and you'll get an output that corresponds to these bad boys.